In this discussion, we will talk about the product rule for differentiation. If a function is defined as a product of two functions, then the derivative of that function equals one of the functions times the derivative of the other plus the other function times the derivative of the first function. So let's look at that with an example. Now let's at least get the product rule stated so we have it in front of us. Let's say we have P equals F times G. Then P prime is F times G prime plus G times F prime. That's the product rule. Okay. Our example, we will choose something fairly simple like y equals x squared times x cubed minus 3x. And we will find the derivative of y. Now, of course, we could just distribute this x squared across this small binomial, and we'd have a polynomial, and we could use the fact that differentiation is linear and apply the product rule, the power rule term by term, and we'd have the derivative. And that's what we would have done before we learned the product rule. But I want to practice the product rule, so we're going to apply the product rule. We're going to find the derivative of y. We're going to take f. Now, we're going to recognize that x squared is a function, and this cubic is a function, so we'll call x squared f, and we'll call the x cubed minus 3x g. Applying the product rule, we take f, which is x squared, and multiply it by the derivative of g. Well, the derivative of g would be 3x squared minus 3. Then we will add to it g, which is the cubic x cubed minus 3x, times the derivative of f, which is, our f was x squared, so the derivative would be 2x. Then we might simplify some. I'm not sure it's too worth it since the gist of this lecture is just to learn how to apply the product rule, but we'll go ahead and simplify some. This would be 3x to the 4 minus 3x squared plus distributing the 2x to the 4 minus 6x squared. So the simplified derivative would be 5x to the 4 minus 9x squared. And since the original function was given to us as a product of factors, we might factor this, but this original function wasn't even factored beautifully, so we might be satisfied with the answer as is. But factoring out the x squared, like was done before, we're left with 5x squared minus 9.